We met. Okay. Dhruv Kumar, it's 1.5 hours to 2 hours. Okay. So this is our multi-threading syllabus. Maybe most of you are aware of this syllabus. So you first, there are, 4 to 5 levels are there in multi-threading. First one is how to create a custom thread. These all points are comes under how can we create a custom thread. Second, okay. Second, what are the life cycle states of the thread? Thread life cycle states. Okay. What are the life cycle states of a thread and algorithms for executing the thread? Third level is what? Different methods available in thread class for obtaining thread properties, like, state of the thread, and next priority of the thread, and next name of the thread, thread ID, next running thread, currently running thread object reference, the next setting thread group, and next what you call printing thread information. Okay, creating types of threads, daemon and non-daemon. There are 2 types of threads. So this all comes under what? Priority. And next is controlling thread execution by using thread class methods, yield method, sleep method, join method, synchronized keyword, wait, notify, notifier. So this is the regular syllabus of your multi-threading chapter. Okay, hope you already know. This workshop is not concentrating. We are not learning all these topics as part of this workshop. This workshop is multi-threading enhancement. As part of multi-threading, we learn how can we create custom thread, right? How many ways we can create custom thread? We can create custom thread in 3 ways. Extending from thread class, implementing from runnable interface, implementing from callable interface. Okay. So these 2 are traditional approaches, means extending from thread class, implementing runnable interface. These 2 are traditional, means Java 1.0 onwards available approaches. From Java 5 version onwards, we have a new approach of implementing custom thread, that is what? Callable. And you must have know this point. What is the meaning of creating a custom thread? So actually, how can we create a custom thread? Custom thread, generally people say we can create custom thread in 2 ways, extending from thread class, implementing from runnable interface. By using these approaches, you are not creating custom thread. You are supplying the logic to execute in custom thread. Okay. The actual way of creating custom thread is only one way. That is what? How can we create custom thread? How can we create custom thread? We can create custom thread by using thread class, create thread class object, and call start method. When you create thread class object and call start method, custom thread is available in the JVM. Okay. But what is the problem in this approach? If you just create thread class object and call start method, what is the problem in this approach? How can I execute my logic in this custom thread? What is the problem with this thread class approach? Okay. But the problem here is, we cannot execute our logic in the custom thread. Okay. Let me try to show you the diagram one more time. Now this is our JVM. Okay. In JVM, this is our method area, and this is heap area, and this is Java stacks area. Right? Runtime data areas are there. In Java stacks area, by default, we have main thread. Inside main thread, main method execution started. whatever the logic you have written inside main method, what are the other methods you are calling inside main method, all are executed in which thread? Main thread. If you execute logic inside main thread, this logic will be sequential execution, also called what? Synchronous execution. Okay, synchronous execution or sequential execution flow. With a sequential flow or synchronous execution flow, what is the problem? Time taking process. And in middle, if something because of some reason execution is passed, other next statements don't have chance to execute. So then how to overcome this problem? Further, we need concurrent flow of execution or asynchronous flow of execution. Repeating again, concurrent flow of execution or asynchronous flow of execution we need. What the meaning of asynchronous or concurrent flow of execution? Let this thread execute. While executing this thread, whenever this thread execution is passed here, now we want execute other thread. Okay, other logic I want execute. To execute in another logic, if you want to execute the logic in another thread, first of all, I have to create this thread. Second, I have to load the logic inside this thread and execute. So these are the 2 points we have to do. So multi-threading is nothing but point number 1, create a custom thread, Point number 2, start that custom thread. Point number 3, load and execute logic in that custom thread. Load and execute logic in that custom thread. So what is the important point? Custom thread you can create. How? By using thread class. You can start the custom thread. How? By calling start method. Okay, we can create a custom thread by using thread class. How? By using thread class object. Create thread class object. Thread object is ready. Call start method. This thread of execution ready. But what is the problem? I cannot execute my logic inside. So what is the problem in the thread class approach? Thread class approach is we cannot execute our logic in custom thread. Then if you want to execute logic in custom thread, what should I do? Just by writing these 2 lines is not sufficient. I have to supply logic to this custom thread. How can I supply logic to the custom thread? In how many ways? 3 ways. If you want to supply the logic to the custom thread, we have 3 ways are there. What are the 3 ways? Number 1, extending from thread class. Number 2, implementing from runnable interface. Number 3, implementing from callable interface. Okay, na? Sai, if you don't know multi-threading chapter, you can leave this workshop. This is multi-threading enhancement, not multi-threading basics. Okay? Or if you wanted to listen, you can continue. This is for multi-threading enhancements to learn, not multi-threading basics. Tell me now. Extending from thread class, implementing runnable interface are the traditional approaches. So only implementing callable is the latest approach. Okay, first, let us try to understand here. Just quickly, I am giving revision. Maybe you forgot or remember, don't know. Tell me now. Here, in extending from thread approach, what are you doing? You are creating one class deriving from thread class. We have already thread class. You are writing a class. Then I wanted to execute logic in the custom thread. The initial point of class logic execution is, the initial point of custom thread execution is run method. The initial point of main thread execution is what? Main method. Whatever logic you write inside a main method, that logic is executed inside main thread. The initial point of custom thread execution is run method. So whatever logic you write inside run method, that logic is executed inside custom thread. Now my question is, where run method is available? Run method is available in 2 places. Number 1, in a runnable interface. What is the first one? Runnable interface. In runnable interface, run method is declared as an abstract method. Okay. Thread class is implementing runnable interface, overriding run method with some logic. Okay, many people are feeling that thread class run method has a dummy logic. No, it has some logic. What is that logic? We will see. And then what are you doing now? I need to override run method. Now you have two options are there. Number one, create a class myThread extending from thread class. Another approach is what? Create myRunnable, nothing but create one class implementing runnable interface with name what? MyRunnable. You override run method here or you override run method here. We have two approaches are there. Then which approach is the best approach? Extending from thread or implementing from runnable? Extending from thread is wrong approach. I mean, I don't say wrong approach. It is not the best approach. Implementing runnable is the best approach. Why implementing runnable is the best approach? What is the problem with extending from thread class? Which approach is best for creating custom thread? Which approach is best for creating a custom thread? Implementing runnable is the best approach. Why? Implementing runnable interface supports multiple inheritance. Also, runnable interface provides parallel development and reusability. Okay, na? Two approaches, I mean, two advantages are there. What is the meaning of it? If I create a class deriving from runnable interface, we can extend from other class. It is not possible with extends from thread class because Java doesn't support multiple inheritance. Okay, a class cannot extending from multiple classes. A class, if it is extending from interface, also extending from other class. Next, runnable interface provide parallel development. This is very important for today's workshop. What is the meaning of parallel development? Tell me now. Observe here. If you remember interface chapter in your core Java, interface meant for providing specification or contract document. It will provide declarations. Okay, one object I am choosing, some object. This object perform first operation, second operation, third operation. All these are operations are declared by using abstract methods. Abstract methods. Once you create this object interface, then at a time, one side, implementation class developers can work at a time. At the same time, other side, user class developers also can develop. Do you know what is the meaning of superclass? What is the meaning of subclasses? What is the meaning of user class? Okay, I don't know whether in your core Java you have divided like this. Whenever you take one object, this object contains business logic, and in order to execute the business logic, I need to have main method class. Na? That main method class, what it will do? It create the instance of this class and call methods. Na? If you have written main method inside the same business logic class, that is a wrong approach. You have to create in a separate class. Okay, this is separate class, generally what? Test class. And this is your object class, is something called example. Now this example class is called what? Business logic class. And this test class, which is calling the methods of this class, is called what? User class. If you come to inheritance, every object contains what? Superclass, subclasses. In order to access these methods and execute these methods, we will create what? User class. Now observe now. Whenever you have the superclass interface, subclasses and you can say subclasses or implementation classes. Okay, implementation classes and then user class, both can be developed by two different developers at a time. That is called what? Parallel development. Now let us apply this point to the multi-threading chapter. Now already we have runnable interface. Everyone understand this point so that executor framework will be easy. Today workshop you can understand. Maximum in just more 5 minutes. I'm going to, already I launched with the knowledge you are having. Already workshop executor framework knowledge already have launched. Within 5 minutes, I'm going to give conclusion. So focus. If you understand this 5 minutes discussion, executor framework is very easy. Tell me, we have runnable interface. Inside runnable interface, we have public void run method already. Okay. Now, who are you? I am the runnable interface implementation programmer implementing one task. This is what? Subclass or implementation class, my runnable. Or else I want to implement one task called what? Addition task or subtraction task or deposit task or some other XYZ task. Okay, database, data analyzing task, data cleaning task. So anything, okay, some XYZ task I am trying to implement. Generally, what we call it as task. Task is nothing but operation. Okay, so here I am writing logic. Try to answer. Here, while developing these classes, anywhere are you using the thread class name? No. What you write? Addition implements runnable. Subtraction implements runnable. Data processing implements runnable. Then tell me, the developer in his system at a time, can he develop or not? Yes. Now, I am taking this side, another developer is working. What is this another developer job? This another developer job is thread creation and starting and managing. Thread creation, starting and managing logic. So there are two logics are there. Thread task execution, task implementation logic, thread creation, starting and managing logic. Now what he is doing here is creating thread class object. Thread th1 equal to what is writing? New thread of what he has to pass? A runnable object as an argument, and writing t1 dot. What method is calling? Start. Tell me, in this logic, am I writing anywhere this addition object creation or subtraction object creation, data processing class logic creation, any object I am creating? No. Now from the main method class at runtime, from the main method class, we will create object and pass as what? Argument. All people now apply your mind and try to understand this logic and this logic developing by two different developers at a time in their computers. Yes. Then this is called what? Parallel development. Everyone understand? This is called parallel development. Tell me, if I implement my class using runnable interface and override run method in subclass and call that run method via thread start method, then tell me, at a time, two developers can work at a time? Yes. That's why in projects, which approach we recommended to use? Extends thread or implements runnable? Implements runnable is the best approach. Everyone understand? So totally, another advantage of runnable interface is once we create this addition object, tell me, can I execute same logic in first thread, same logic in second thread, same logic in third thread? Yes. That means this is called what? Code reusability. How many times you have written logic? One time. And how many times you are using that logic? Multiple times. So if you follow implementing runnable interface approach to supply the logic, there are three advantages are there. Number one, multiple inheritance is possible. Number two, parallel development is possible. Number three, code reusability possible. Because of these three advantages in a company, we are going to develop what? We are going to develop custom thread creation by following runnable interface. Can you please confirm up to here? Everyone understand? Yeah, game development is one test case. Multi-threading, not only for game, most of the cases, don't say like that. That is a one application. Game development is one application. That's it. Now I want to ask a question. Everyone listen. Thread concept, is it Java specific concept? Thread is Java specific concept or OS specific concept? Everyone. Thread is Java specific or OS specific? It is OS specific. It's not Java. Multi-threading API is native API. It is Java API, means its method declaration is available in Java, but its implementation available what? Native. Let me show you that. Now you created thread class and call start method F3. Open start method. Look at here. Start method defined in which language? Java. It implicitly calling start 0, F3. What is this? Native method. That means this logic is developed in Java na in C and C++. C and C++. Why C and C++? Because OS is developed in C and C++. You take many methods are there. Suppose I am calling sleep method. Thread dot sleep. Thread dot sleep of 100. F3. Sleep 0 after sleep. This is Java for our Java level verification purpose, just validations purpose. Click on again what method? Native method. 90% of the methods in thread class are native. What is the meaning of native? Thread API is developed in native language, means C and C++. It is OS specific. Now, I have a question. This is our OS. Everyone, please understand. This is OS. This is our JVM. What is JVM? JVM is a process. Inside process, now the threads are created. Thread 1, thread 2, thread 3. Sanjay Kumar. Are you core Java student? Are you learning core Java or completed core Java? Completed. Sir, ask that question, please don't ask anywhere, sir. This is the most dangerous question, sir. It will kill your interview success. Okay? Which version thread API comes ante, that's really bad. Asal Java doesn't work without thread, na? If you run Java command, JVM, your entire program is executed by one thread called main. Do you know it? Without main thread, single line of your Java program is not executed. That means this thread API is available from which version? 1.0. I think you learn in a wrong way. Check once. Sheikh Shahrukh, you didn't read the workshop heading? Java multi-threading enhancements. You should know multi-threading already. If you don't know multi-threading, you cannot understand this class. Happily take rest. Everyone. Operating system has, inside operating system we have JVM. What is JVM? Process. Inside JVM, we are creating thread 1. Yo, now you know many is a thread. Okay. Thread 1, thread 2, thread 3. Okay, what is the first thread available? Main thread. Okay, first thread started is what? Main thread. Then from the main thread, we are spamming or we are creating the new threads. What is that? Thread 1, thread 2, thread 3. Everyone try to understand? Like this, I am creating hundreds of threads, thousands of threads, lakhs of threads. Then is it a burden on the JVM or not? At some point of the time, JVM will die, na? Shall we try one small program for proving that? Okay. For proving, I wanted to write small program quickly. Let's see. I want you feel it. Okay. Test. What is our number? 20. 20. Okay. Let me take 31 because still we need to write some more programs in tomorrow class. test 31 finish. Class my thread 31 extends thread. Okay, now I am writing run method. This is main method. You can take implementing runnable or extend thread, not a problem here. Okay. My thread 31 empty equals to new my thread 31 empty dot start. Then what happened? Because of start, control is coming into run. Here I am writing system dot out dot println. Can you tell me how can I get the thread name? Thread dot current thread dot current thread dot get name. Actually, this class is extending from thread. So we no need to write thread dot current thread dot. Directly we can write get name plus double quotes start and double quotes end. Between what am I doing? Okay, let me run this program. What is output get? Thread 0 start, thread 0 end. Between what I am doing, my thread, same class object again I am creating. Empty equal to new my thread. Can I create a custom thread from other custom thread? Yes. New my thread 31 empty dot start. What happened now? Tell me the diagrammatic explanation here. This is our JVM. Inside JVM, main thread is by default available. Main method loaded, running. Inside main method, I created thread object and calling what? Start. Then control started one custom thread. What logic is loaded? Run method loaded. And this logic executing here. What you did here? You created one more thread object. This is Java stacks area and this is heap area. Do you guys know for main thread also one thread object available in JVM? For main thread also one thread object is available inside JVM. Okay. Then next we from the main method we created a custom thread object and call a start method. For this custom thread object we created. This object is main thread. Then when I call start method, thread of execution started, it is holding it. Now from this custom thread, you created one more thread object, na? Then you call start method. From this child thread, one more thread is born. Understanding? One more thread is born. What happened? Tell me. This thread is holding this object. After into this new thread, different run method loaded or same run method loaded? Same run method is loaded. That means this logic is again executing or not? One more custom thread is created, started, created, started, created, started. Then tell me, is it finite flow of execution or infinite flow of execution? Infinite flow of execution. All people understand? Control F11. It's never stopped. But if you carefully observe, it keep on running only, but our system will not be slow and system will not be die because every time what happen, observe, start and start and start and noticed? This thread run method completed. Every time started, close. And at a time, how many threads are available inside JVM? One or two threads only available. Is there any burden to the JVM? No. Started, other thread is started, end. Second thread started, other thread start, new thread started, end. Like this, it's keep on running. Every time it is terminating the previously created thread. But now what I am doing now, observe here. Now let me stop this. Lakhs of threads will be created and destroying, no problem. Now here I'm going to write while loop, infinite loop I am writing with true. Okay, this end I am deleting, okay? While true. While true means it's completed or never completed. Never completed. Observe now. The same diagram is same. Previously, once new thread created, old thread is completed and terminated. But now what happened? Second thread, third thread, fourth thread, they keep on running, not destroyed. No, they are holding. Then the number of threads are increasing. Look, slowly, execution becomes slow. System becomes slow. Previously, just like that, you got lakhs of threads number. But now, lakhs of numbers coming up, slowly going up. Slowly, look at there. Now, 1 second, 2 second, 3 second. Second one coming, becoming more slow. 1.5 second. More becomes slow, na? Practically able to see, na? And tell me, threads are part of JVM. Can JVM hold infinite number of threads? Can it manage? No. Become now 2 seconds. Ayyo, such pain it is. Okay. Finally, I want you to realize one important point. First point I want. No, we'll get out of memory error. Stack Overflow will not get out of memory. If you leave this program like this, at some point of the time, we will get out of memory error and JVM will terminate. Okay. So now my question is, finally, what you want to understand? Threads are not part of JVM. It's a part of what? OS. Okay. Then how many threads JVM or OS can hold? Not infinite number of threads. There is a limitation. Up to now, all the people understand? Now I want a final one question. That is, in your project, one developer developing or many developers are developing? Many developers. If every developer creating their own threads, I am creating as many number of threads as I wish. In his class, he is creating as many number of threads as he wish. And other developer creating as many number of threads as he wish. Is it a good idea of creating every programmer by themselves number of threads? Bad idea, because it affects our performance of the application. Every developer is having one task to run in the custom thread. So you develop your task and other developer develop his own task. 100 developers are developing their own tasks. But all these 100 tasks to execute by individual threads is a good idea, bad idea? Bad idea. Performance of the application is affecting. So, Sun Microsystem has come up with an idea in Java 5 version with a concept called what? Thread pool. What the concept? Thread pool or executor framework. Thread pool or executor framework. Now look at that. Almost it is now coming one message after 2 seconds, 3 seconds, even if after 1 minute also. So shall I stop now? I hope you understand now. Now I am terminating JVM process. Stop. Okay. Now. Yeah, Neeraj, virtual threads and all I don't want to discuss. That is the latest version concept. Okay. No problem. So now come back now. What is the point I'm trying to tell? Now, initially from Java 1.0 version to Java 1.4 version, in our project, we have to create a thread by ourselves manually, and we have to run our task manually and complete the task. That is what one approach. In Java 5 version, we come up with, Sun Microsystem come up with one new feature called executor framework, also call it as a thread pool. What is the meaning of executor framework? Framework is nothing but a set of classes and interfaces providing the abstraction on low-level services. Set of classes and interfaces providing abstraction on low-level services. Tell me, if you want to create a thread, is it a Java code or OS level code? OS level code. You and me, everyone has to develop actually thread creation logic. Instead of you and me creating, Sun Microsystem has given a one class called what? Thread. This is actually abstraction. They provided the required logic for creating thread by using the class called what? Thread. But still, we found some more problems. All developers are creating their own. But now Sun Microsystem decided, from Java 5 onwards, you don't show your talent of creating thread. Ask me, I will create. So we got a concept called what? Thread pool. Now you should ask JVM, for my project, you create me 5 threads. Okay. Thread 1, thread 2, thread 3, thread 4, thread 5. 5 threads are created. Who created? JVM. You are not creating. Okay. That means you are not writing this logic. From Java 5 version onwards, you are not writing this logic. Thread 3h1 in new thread, my thread empty1 new my thread, you are not writing. So your first step, you are asking the JVM, please create 5 threads for me. Then first developer, second developer, third developer, fourth developer, all are approaching to this thread pool. Submitting. What are you doing? You are submitting your task to this pool. Then the pool will take your task and assign to thread 1. Then thread 1 is running your task. Listen, after your task execution completed, suppose if I don't have here, after your task completed, now the thread is terminating or not? Can you reuse the thread after for executing the same task one more time? No. So if you create the thread manually, what is the problem? 2 problems are there. If a number of threads are increased, performance of the application is decreased. Second, the thread you created manually cannot be reused for one more task to execute. One task, one thread of execution. Second task you want to execute, you have to create one more thread of execution, one more thread of execution. But now thread pool thread you can reuse. Listen, how many threads are available here? 5 tasks. At a time, I have submitted 5 tasks at a time. 5 tasks I submitted. First task are given to first thread, second task to second thread, third task, fourth task, fifth task. All 5 tasks are submitted. Now, one more task I am submitting the pool. Is there any free thread is available to accept this task? No. Then you wait. This task will be put in a waiting state. All are catching my point? One more task, one more. Suppose I gave 10 tasks at a time. Then this pool can handle how many tasks at a time? 5. Remaining 5 tasks or 6 tasks will be in a waiting state. Then whichever the thread become free. Okay, suppose thread 1 finish its a task 1 execution. It become free na? Immediately, this is 6th task will be assigned to the first thread. Tell me which approach is best? You want to create and destroy approach is better. Create and reuse is better. Create and reuse. Let me take one example. In Hyderabad, similar to JDBC connection pool. Suppose in Hyderabad, and you take one village. Hyderabad you take and village you take. In village you have more traffic, Hyderabad more traffic. Why? More people and every person is having his own vehicle. In village, less number of people and less number of vehicles. Okay, na? Now, because number of vehicles are increasing, pollution is increasing, many other problems are coming. And moreover, cost is increasing. If every person has his own vehicle, then the petrol is consuming more, maintenance increasing more. That's why this is a problem in Hyderabad. Transport is a problem. That's why one company came forward called Ola. Ola cabs, By seeing Ola, we got Uber. By seeing Uber, we got Rapido. Ola and Uber focus only on rich people. Rapid focused on poor people also. Correct? Bike, Rapido bike, right? Tell me, after Uber, Ola came to market, then the number of vehicles usage is decreased. What happened? Ola company is telling or Uber company is telling that, we have pool of vehicles. Okay, first car, second car, fourth car, fifth car, we have cars. Then one person wanted to travel. Then what he has to do? Is he buying his own vehicle? No. He is hiring one vehicle. He is using for his service. After his service completed, is he destroying that vehicle? No. Then what is doing? He is return that vehicle back to the pool, and it is make it available for other customer to use the service. All right, following? So tell me, this Rapido, this Uber, this Ola, these are nothing but what? Our thread pool. Understood? Now tell me, this bike or this car are nothing but what? Threads. And this person who want to travel is nothing but what? Service. Or nothing but task. Can you all understand now? And the executive framework completed. Here deadlock will not work. It will not come because other threads.
Other thread is waiting for some other thread. Then how it is interacting and changing.
I didn't understand your question. Okay, this is a one individual task. Okay, this task is working on one object. Second task you are submitting not with the same object. You are submitting with another new object. Okay. Then suppose you invoke this method on synchronized method. Okay, because many people may not know. Today discussion is only on executive framework, synchronization, re-intent locks. That is coming workshop. No problem. Because you asked the question, I will explain. On this object, you have called one synchronized method. Then what happened? This object is locked. This thread become monitor of this object and it is accessing this object. Second task you are submitting with another new object. Synchronized method is called on new object. Then second thread is accessing what object? Second object is locked and executed. Sir, suppose both synchronized methods I call with the same object. Okay, then this thread wait for unlocking. What is the difference between our manual thread creation and thread pool creation? Instead of you creating, JVM create. But synchronized concept wise execution, other sleep method, wait method, join method, the fundamentals of multi-threading is same. Either manual you create or pool wise you create. Creation wise only the different, but remaining all points are same. If this thread is waiting for the lock on an object, it has to wait. And will it given for other threads? No, it has to wait because already taken task na. Until this first thread complete its execution and release the object, until then it has to wait. If it is not releasing, that is also will be in a waiting state. So these two threads are in busy. Then other threads will be free threads na. Those free threads will serve the other task. If these threads also become waiting, then entire system will be waiting. Understood? So there is no difference between old style and executor frame style. Both are all are same. The only difference is the way you are creating and reuse. So finally, hope you got clarity on thread pool concept. Now, are you feeling that yes, in projects I should not create my own thread? I should use what? Pool threads. I should use execution execution framework, executor framework. I have to use that creation. That thought should come. Today onwards, whenever you go outside on the road, okay, whenever you go outside on the road, whenever you see Uber is going, hey, one thread running on the road. Rapido person, recall helmet Rapido going. Oh, another thread going, servicer. Okay. If somebody is there backside on the Rapido bike, then means what? Oh, already busy with this task execution. After 10 minutes, this thread will be free, waiting on the road for another task to accept. Niraj, this class is for that purpose only, na? I will show the example, just the theory completed. Now is the time we have to go for practicals. Krishna Gupta, asynchronous mechanism is nothing but This is main thread. Here you started one new thread. Okay. It is going in its own way. It is going in its own way. This is called asynchronous. Understood? Krishna Gupta. Multi-threading is nothing but concurrent flow. Concurrent flow is nothing but asynchronous. You run your way, I will run my way. No dependency between them. That is called asynchronous. I have not started anything about thread pool concept. Just I gave theory. Okay, you are shooting many questions. Okay, good. The doubts should come. Nice. And now I want you answer few questions here. Let's answer them. First question. Question number 34. What is executor framework? Okay, this is the first question. Second question. What is thread pool? Next question. With this theory, whatever you understood. Next question. How can we... Okay. How can we... What is the API available as part of executor framework? Executor framework. Next. What is the purpose of each class and interface? What is the purpose of each class and interface? Okay. Next. Very, very important question. What are the different ways we can start thread pool or create or start? Okay. Create and start. What are the different ways we can create or start thread pool? Okay. First, let us understand these questions. Tell me, what is a executor framework? Executor framework is a framework. What is a framework? Framework is nothing but set of classes and interfaces. Those set of classes and interfaces are meant for what? Creating and starting and managing a pool of threads. So what is the executor framework? A set of classes and interfaces meant for starting, creating, starting and managing pool of threads together is called what? Executor framework. And tell me, what is executor framework? A set of interfaces and classes. Okay, interfaces, their implementation classes and utility classes. Okay, set of interfaces and classes meant for creating, starting and managing pool of threads are called executor framework. Okay, executor framework. Simple definition. So whenever I say executor framework, it's simple. It is just a interfaces and classes. What it is doing? It provides abstraction. It provides abstraction layer, I can say, abstraction layer in creating, starting and managing threads in an automated way. Same point one more time is I'm going to write here. Executor framework provides an abstraction. All the people know what the meaning of abstraction. Abstraction means hiding implementation details, right? Abstraction layer for creating, starting and managing multiple threads in an automated way. So that means by following executor framework, we no need to create threads. We no need to manage the threads. We no need to start. It will be automatically done. So what is an executor framework? Advantages. What are the advantages of executor framework? We are free, not free. We are free from, number one, creating threads manually. Next, second, starting threads manually. Same points are coming again and again, okay? Starting thread manually. Number two, we can reuse those threads for running multiple tasks. Okay, simply we need to only concentrate on business logic development. We need to concentrate only on business logic development. Earlier, you have to learn how to create a thread, how to start the thread, how to manage the thread, and how to develop business logic. That means business logic and thread creation logic. Both logics you only need to write. With executor framework, you need to concentrate only on business logic. Next, what is a thread pool? What is a thread pool? A group of reusable threads. A group of reusable threads is called thread pool. And tell me, to create thread pool, do I need to write any logic? No. Executor framework has provided several interfaces and classes for creating thread pool. Okay, then what is the API available as part of executor framework? Executor framework interfaces and classes are provided in the package. What the package? java.util.concurrent. What the package name? java.util.concurrent. Okay. As part of this package, for executor framework or for thread pool creation, we have below interfaces and classes. Try to understand the terminology, little confusion. Okay, initial I also confused. That's why slowly I am typing everything. First one is executor. What is the first one? Executor. First one is executor. Then second one is executor service. Third one is scheduled executor service. First one is executor service, scheduled executor service. Okay. Next, fourth one is executors. Executors, plural. Oops. Okay, na? Executors. If you people know collection, we have an interface called collection, and we have a concrete class called what? Collections. Executors. Next, fifth one, future. Okay, future. In Java 8 version, we have future subclass called completable future. Maybe today time will not be sufficient for teaching you completable future. In another workshop, we will discuss. Okay, na? So here, up to here, we will complete. Next week, definitely, I will take one more workshop on the next enhancements on multi-threading. So this is first level, and we have multi-threading completable future is there. Re-entrant locks are there. Blocking queues are there. Okay, so those topics we will plan next week for 2 hours, and we'll complete them. And next, this is sixth one, and seventh, we have something called execution exception. I just want to take, these are the main points. And in java.util package, we have some other classes also as part for collection API purpose, and even for multi-threading enhancements also, we have some more classes, but I don't want to discuss all those things. Okay, this workshop, I want to focus only this much. Executor service, scheduled executor service, executors, future, completable future, execution exception. Now, what is these three are? These three are interfaces. And executors is a class. Future is also interface. Completable future class. Execution exception is a exception class. Okay, let me tell you slowly one by one. Executor is an interface, comma, it is the super interface. It is the super interface. Next, executor service is also an interface, comma, it is the sub-interface of executor. Okay. Next, what is scheduled executor service? Is also interface, is also an interface. It is the sub-interface of executor service. Okay, what is the hierarchy here? Executor, this is the hierarchy. Scheduled executor service is the sub-interface of executor service. Executor service is the sub-interface of executor. So tell me, thread pool is managed by which interface? Executor. Now you should ask one question. Sir, when executor already there, why executor service came? When executor service already there, why scheduled executor service all coming? Okay. When person is there, why student coming? When student is there, why BTech student is coming? When BTech student is there, why MCA student is coming? When student already there, why faculty is coming? Because speciality. Person is the base type. It provide only base features. I want more features, specialized features. Then we have specialized objects are coming. Similarly, Executor is providing basic functionality. Thread pool basic functionality. I want more functionality, then use executor service. I want scheduled threads. I don't want run the thread immediately. Okay. I want schedule. Okay. I want to specify the time. At that time, it should execute. If you take executor service, immediately thread is executed. I want to execute upon a scheduled time. Then you have to use what? Scheduled executor service. So executor is a interface with minimum functionality. Executor service is a sub-interface of executor with advanced functionality. What is that advanced functionality? I'll tell you. Scheduled executor service is meant for running the task upon the scheduled time. Okay. Then what the purpose of executors? What is this executors? Is executors is a class or interface? It is a class. It is a class. Executors is an factory class, factory or utility. Utility class. It has factory methods to start thread pool. Understood? Tell me. Executor is a interface. Abba. Can you create interface object? No. To create interface object, we need implementation class. That implementation class object we required or not? Instead of you create implementation class and instead of you create the object of that implementation class, we have been given one class called what? Executors. In this executor class, we have the required number of methods to start the thread pool. Simply, we have to call that factory method. If you attend advanced Java, in advanced Java, we have interface called connection. We have an interface called statement. This connection has multiple implementation classes based on the database. In order to get this connection interface subclass object, are you creating object or calling one method? What that method? Driver manager dot get connection. Remember? You want to create statement, prepared statement, callable statement object. Are you creating object or calling one method? Calling one method. What that method? Con dot create statement, con dot prepared statement, prepare statement. And tell me what all these methods are? Factory methods. Right? Factory method is a method that creates and returns the object. Similarly, if you want to create the thread pool, you don't need to create an object. Just we need to call factory method. Factory methods available in which class? Executors. Up to now, understand? Now, up to here, I wanted to verify a program and also I wanted to verify what you call one, API documentation. Where I collected all this information, you should also know that. In future, in company, who will teach all these enhancements? Every time will you come and attend workshop, waiting for my workshop? It's a bad idea. So in your company, whenever you need any additional concept you want to learn, you have to depend on API documentation. So which version you wanted to know? Latest version. Okay. Java 21, latest version, Java 21 version, API documentation. Search, you will find one link. Click on this overview. This is API documentation. API documentation is nothing but a HTML file that contains complete details about the predefined classes. Now here in the search box, you type which interface? Executor. You want to know about executor. Type executor. Observe java.util.concurrent.executor coming na. Click on this. Look, where it is available in the package? Java.util. It is what now? Interface. What are the sub-interfaces? Executor service, schedule executor service. What are the implemented classes? Abstract executor service, fork join pool, scheduled thread pool executor, thread pool executor. These are what? Subclasses. Do you need to remember these subclass names? Not required. Public interface executor. Please read this point. An object that executes submitted runnable task. Earlier you submitted runnable task to which class? Thread class. What you did? You created thread th1 equal to new thread of, you pass mr, my runnable object you pass, remember? And then you call what? t1 dot start. t1 dot start you are calling. Tell me, here thread accepting your runnable task executed in the custom thread and this thread of execution is destroyed. Ardhamainda? Understand? Now, if you want to execute this task or another task one more time, can I reuse this thread 1? No. Again, you have to repeat again the code. Thread th2 equal to new thread of mr mr2, whatever the new task. Then you have to call what? th2.task. Then tell me, burden on the OS is increasing to create the thread, run the thread, destroy the thread. Performance is decreasing or not? What is the difference between thread-wise executing runnable, executor-wise executing runnable? If you run via thread, performance is low. If you run via executor, performance is more. Understood? Reusability is there. And moreover, I no need to focus on this threads creation. I need to focus only on implementing my business logic. An object, executor is an object that executes submitted runnable task. This interface provides a way of decoupling and separating. Decoupling task submission from mechanism of how each task will be run, including details of thread use, scheduling, etc. I told you na. Tell me now. If I take a thread class, I have to do number 1, task implementation logic. I only has to develop. Second, thread creation logic. I only has to develop. Number 3, thread starting logic. I only has to develop. Number 4, thread managing logic. I only has to develop. So all these 4 tasks I only has to develop. If I use executor, only focus on task implementation. This thread creation, starting, managing, this work is done by whom now? Executor. That's what decoupling point. Okay, na? Everyone understand? Then now very important point now. Observe. An executor is normally used instead of explicitly creating threads. For example, look at that. New thread of new runnable task dot start. Instead of you running, what you do? Use executor. There is a method called what? Execute. Pass what now? Runnable task 1. Are you using same executor or different executor? Same executor. Earlier, can you use the same thread? No. Now are you using new executor or same executor? Same executor, new task. Third, same executor, third task. Okay. Then next question. When we have already executor, then why do we need which version onwards available? 1.5. It has only one method called what? Execute. Only one method, execute and supply what? Runnable. Now the question is, when we have already executor, why we need a sub interface called executor service? Click on it and you will understand it. Observe. Executor service is also what? Interface. It is an sub interfaces. What are the sub interface? Scheduled executor service. What are the implementation classes? All these classes. Okay. Now, what is this executor service? An executor that provides methods to manage termination and methods that can provide future for tracking the progress of one or more asynchronous tasks. Okay, you may not understand this point. Hold. I will explain. Once I write a program, you will understand this sentence. An executor service can be shut down. And the executor, can you shut down? No. Manually, you have to shut down. Automated way, you cannot shut down, which will cause it reject new tasks. 2 different methods are provided. Shut down. Okay. Okay. Let me go down. You'll understand one more point. If you go down, as part of the methods, if you observe, there is a method called, observe, there is a method called what? Submit, which will take what? Runnable. And we have one more method called submit with what method? Callable. I told you, na, service, executor service is providing extra functionality than executor. Executor will accept only runnable type task to execute, and you cannot shut down it. Programmatically, you have to shut down it manual. If you want reuse, it should keep on running, na? Right? Now tell me, if I use executor service, I have 2 advantages. Advantage number 1, I can execute runnable task. Also, I can execute callable task. Sir, what is the difference between runnable task and callable task? I will explain. So, first advantage of executor service, I can execute what? Callable task. Second advantage of executor service, whenever I want, I can shut down it and stop accepting new tasks. Suppose you take the driver. Rapid driver you take. Rapido driver, can he stop? Can he exit from the Rapido app to take the rest at any time? Is it having is it in easy control or not? If Rapido is controlling, hey, you are not allowed to exit from the app. Whenever I say only you exit, and is it a good idea, bad idea? Bad idea. So whenever I want to shut down, I wanted to shut down. New tasks, I don't want to accept, I want to close. Is that facility available in executor interface? No, that facility is available in executor service interface. Executor service is an executor with the two extra function that will accept callable service to execute. Number two, we can shut down whenever I want. Is it accept and understand? Then tell me, in the project, are you using executor or executor service? Executor service. Now my question, what is callable? I will explain you. Okay, first understand this point. Then how to start this executor service or how to start this executor? For that we need not that callable, Neeraj. That is last batch also one student said same point. Sir, callable is a PLSQL method execution. No. JDBC callable statement is different. This callable. Okay. Both are not same. Observe now. Executor service. When I click on executor service, if you go down, you'll find one more information here. See also. There are. Achha, it's not available. Sorry, whatever. Let me take here executors. For the class executors, click on executors. Observe now, class executors, read it. It is a factory, or the class executors contains factory and utility methods for executor, executor service, schedule executor service, thread factory, and callable classes defined in this package. It provides factory method for creating these objects. This class supports the following kind of methods. Method that create and return an executor service. Method that create and return a schedule executor service. Method that create and return a wrapper on executor service. Methods for create and return thread factory. Method that create and return callable. That means this, if you want to start a thread pool executor service object, you have to use what? Executors. Observe now, I wanted to list out the methods. What are the methods available in this class? There are totally 5 methods available. What are the 5 methods? Carefully observe. Number 1. Okay, there are several methods are there. We don't worry about all the methods. If you scroll down, you'll find, look at there is a one method called what? New catched thread pool. Copy this. Come to our Eclipse. Add this. Next, go down. There is another method I am not considering. New fixed thread pool. Look at this. Take this method and click on this. Next, scroll down. Here you find one more method here. New scheduled thread pool. Last 5 to 10 minutes, buddy. Please bear. Next, we have one more method is there. Single thread pool executor. Observe. We need to call these methods. Next, thread schedule executor. That's it. These are the 5 methods. Remaining methods, you no need to worry. Only we need to consider these 5 methods. First one is what? Public. And second one, public. Third one, public. Fourth one. Look at here. Executor service. What is the first method available? I want to create an executor service with how many threads? 1 thread. What method I have to call? Single thread executor. I wanted to execute. I want to create an executor service, nothing but thread pool with fixed number of thread. I have to specify that number. Someone has asked the question, sir, how can we specify the number? How many threads required? and I want increase or decrease number of threads. How is it possible? By calling these methods. Okay, I want only one thread in the pool. Then what method I have to call? Single thread executor. I wanted to create a thread with 5 threads upon my request, upon my requirement. Then which method I have to call? New fixed thread pool. I want dynamic number of threads. I don't want to decide. I want JVM only decide how many threads should be created. Then we have to use what method? New catched thread pool. Okay, Nana? So totally how many methods we have? 3 methods. If you want to create executor service based threads immediately to start, you have to call single thread executor, new fixed thread pool, and next new catched thread pool. Clear? Now, no sir, I want schedule, and then you have to use what method? Same, new single thread executor, like new single thread executor. Next, new schedule thread pool by specifying the number. So interviewer will ask a question. How many ways we can create thread pool? How many ways? 5 ways. First way, new single thread pool, new single thread executor, new fixed thread pool, new catched thread pool. Everyone understand? Next, fourth one is what? New single thread schedule executor and new single thread pool schedule, new schedule thread pool into the specify you number. Now tell me, scheduling all we don't worry. We wanted to worry about these 3 methods. Are you ready for the program now? You got all the required API, all the information you got. Let us quickly revise the points and we'll start the programming. Okay. Observe now. What is an executor framework? Executor framework is nothing but set of classes and interfaces meant for creating pool of threads. What the advantage of executor framework? We no need to worry about creating thread, starting threads, managing the threads. We will focus only on business logic. Number 2, the threads created as part of executor framework, we can reuse them, no need to create. So that burden on the JVM is not increasing, performance of the application will be more. Next, what is thread pool? A group of threads is nothing but a group of reusable threads is nothing but thread pool. How can we create thread pool? We have predefined API. What is the API available as part of executor framework? Interface called executor, interface called executor service, interface called schedule executor service, and then executors. And next one, future. Okay, what is the purpose of each class and interface? Just now I gave executor service meant for creating the pool. Executors class is meant for, is contain the factory methods to create executor and executor service. Next, what are the different ways we can create and start thread pool? In 5 ways. What are the 5 ways? The methods you have to remember. Okay, now let's start understanding how to create thread pool. What the first step I have to do? I have, let me create one program here instead of disturbing it. Class test 32 main method. Tell me now. Let me close this and open again. What the first step I have to write? Executor service. Executor service. Executor service. Service equal to I have to write new executor service, executors. Executors dot what is the method? I want to create one single thread. Then what write? New single thread executor. You must remember these methods by heart. This is service 1. I want to create one more thread pool, service 2, with what? New new fixed thread pool, right? New fixed thread pool. How many? 5. I want 5. Next, I want one more thread pool, service 3 equal to executors dot new fixed catch, new catched thread pool, no number. Okay, I will do one thing. Instead of taking 3 variables, I want to take 1 variable. Service equal to Okay. At a time, 3 pools I don't want to use. 1 pool only I wanted to use. Save it. Now, I want to submit a task to execute in this pool. What is the method? Tell me, by calling new single thread executor, what happened here? Pool is created. Come on, guys. By calling this, what happened? Background, pool is created. This is thread pool. Inside thread pool, how many threads are created? 1 thread. Hello, you no need to call start method. Understand? This line is creating what? Step number 1, thread pool. Step number 2, with 1 thread, ready to execute. Then what I have to do? I should submit the task to execute. Tell me, what I should write here? Service dot. What is the method I told to submit? Submit method. Submit of what I should pass? Runnable. Everyone tell me. You know, right? Runnable is a functional interface. How can implement functional interface? 4 ways. Number 1, by using outer class. Number 2, by using anonymous inner class. Number 3, by using lambda expression. Number 4, by using method reference. Now, I want to use lambda expression. Can you understand now? All you people know lambda expression? Lambda expression, run method, no parameter arrow, some logic I am writing, system.out.println and double quotes, run executed. Just one dummy logic I am writing, run executed. Tell me, what are you doing here? Here, this is your runnable task. That runnable task you submitted to submit method. Now the runnable task is executed. Nothing but one passenger, one customer has booked the Rapido bike. Rapido bike is assigned to this passenger for traveling. Is it clear? Now, do I need to do anything extra here? No. That's all. Your job is over. What you did first? Simple. You have to write this statement, and what you need to do? Submit. Khatam. No thread creation, no start method call, nothing. Control. Okay, let me show you asynchronous execution or not. It is double quotes, main start, and this one is what? Main end. Main start, main end. Save it. Observe, main start, main end. So tell me, when you call submit method, is main thread execution blocked here? No. What is the meaning of asynchronous execution? Just going in its own path, other threads and other pools are created. That is called what? Asynchronous. When you call submit method, programming main thread execution is not blocked. Main thread execution is continue running, and whenever main thread execution is passed or completed, then this thread got a chance to execute. That is called what? Asynchronous execution or concurrent flow of execution. Observe now what output you got? Run executed now. Can you tell me, how can we know in which thread this run method is executing? I want to know the name of this thread. Can you get the name of the thread? How? Thread dot current thread dot get name. You know all these points. Thread dot current thread dot get name. Look at there. What the name of the thread? Look at there. What the name of the pool? Pool 1. What the name of the thread? Thread-1. Run executed. Clear? Tell me, in this pool, how many threads are there? 1 thread. Now I am submitting multiple tasks. Can I submit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tasks I submitted. Tell me, all these 10 tasks are executed sequentially now, concurrently now. Think. You are submitting all these tasks to which thread? Pool thread. In this pool, how many threads are there? Then where is concurrent? In a Rapido, only 1 bike is there. Then 10 people send the request for the service. Then this Rapido driver can serve to 10 people at a time? One after one? Na? Hello, Adhyaksha. Understood, online students? This is a single thread. Okay, it is a single thread. Inside thread, there are two concepts are there. Now observe. This is our pool 1. Inside pool 1, we have how many threads? 1 thread. And there is a queue. Understand? There is a queue. Is a submit method executing task or submitting task? Submitting task. It is a queue. First task submitted. Task 1. This is thread 1. Pool 1 contain thread 1. Task 1, task 2, task 3, task 10. Submit method is not executing thread. It is only submitting. All these lines are keep on running. Asynchronous submitting. Then main thread completed. Now the JVM will go to pool. Now to this thread, task 1 is assigned. Task 1 completed. Now, from the queue, second task is taken, submitted. Third task is taken, submitted. Fourth task is taken, submitted. Understand my point? How many threads are in the pool? One thread is there. So, all these 10 tasks are executed one after one sequentially. Observe. Run executed, run executed, run executed. Where executing? All are executing in same thread. Asynchronously, they are going sequentially. Main and somewhere in the middle, thread 1 complete. All the 10 tasks are executed by how many threads, sir? Single thread. Oh, no, sir, I want concurrent flow, sir. Okay. If you want concurrent flow, increase number of threads. If you want concurrent flow means what? At a time, 3 tasks or 4 tasks at a time you want to execute. Increase number of tasks, number of threads. How to increase number of threads? I have to use another factory method. Service equal to, come on, executors dot new fixed thread pool. New fixed thread pool. How many threads I want? 3. Tell me. How many? Now pool is created with how many threads? 3 threads. Everyone tell me. At a time now, how many tasks can execute now? 3 tasks. How many tasks I submitted? 10 tasks. First task, second task, third task are submitted to three things. Okay. Now the remaining tasks are submitted or paused. They are blocked, waiting. Okay, na? Observe now. Control F11. There is no rule that first thread only first submitted. Okay. Any order will be submitted. Second task, second thread. Look at that. Totally how many threads are there? 1, 2, 3. 3 threads are there. Third thread is the first picking and assign the task. Okay. Control F11. Or else let me do one thing here for your better understanding. I am writing here. Run 1, run 2, run 3, run 4, run 5, run 6, run 7, run 8, run 9, run 10. Look at that. Now properly coming. Look at that. First 3 tasks are submitted to 3 threads. Then remaining tasks are in block in a queue. Now first thread is become free. Thread 1, run 4. Immediately thread 2, thread 3 not become free. Thread 1 only become free. Then run 5 taken. Thread 2 become free. Run 6. Again thread 1 become free. Then run 7. Oh, thread 1 is racing. Hey, I am Rao. Okay. Thread 3 become free now. Run 8. Thread 2 run 9. Thread 1 run 10. So all the 10 tasks are managed by how many threads now? Thread pool is reusable or not? Able to now visualize now? You have to practice this a simple example. Okay. Is the service still running? Is the service still running or not? Can you see now? Red color. Red color means what? Still running. Why? Because it's a pool. Threads are meant for reusable. Currently, how many tasks is submitted? 10 tasks. After serving all these 10 tasks executed, threads are still waiting. Yeah. Any other customer there to take my service? No, no other customer. Then, if it is a executor, you have to stop manually. If it is a executor service, You can stop with a program. Service dot shutdown. There is a method called what? Shutdown. Control F11. Look at the service is shut down. Na? Red color not there. It is automatically shut down. There are two methods are there. What are the two methods? Shutdown and shutdown now. What the difference between shutdown and shutdown now? Shutdown will shut down the service after all submitted tasks are executed. By the time you call shutdown method, how many tasks you submitted? 10 tasks. But how many tasks at a time can execute? 3 tasks. Remaining 7 tasks are in the queue. Until all the 7 tasks completed, now this service will be waiting. If you call shutdown now, what is the meaning of now? When this method executed, immediately shut down. Can you guarantee all the 10 tasks are executed? No. How many executed? 8. Run one more time. This time how many executed? Again 8. Actually 10 submitted. This time have a chance to execute 10. Again execute. This time how many got chance? 7 to execute. Understand the shutdown difference? Interviewer may ask the question, what is the difference between, how can we shut down the pool by using two methods, shutdown and shutdown now? What is the difference between them? Shutdown method wait for all the submitted tasks to execute. Shutdown now will shut down immediately. Even though there are some threads in the, even though there are some tasks in the queue, it will not wait for the service to execute. So let me take shutdown. Up to now, all you understand? Now, instead of, instead of I am specifying the how many threads to create, I am asking executor to decide how many pools to create. Then what method I have to call? New catched thread pool. New catched thread pool. And here I am writing, remove this. Did I mention how many threads to create? No. This is how many? Fixed 1. This is how many? Fixed 3. This is how many? Dynamic. How many tasks I have submitted? 10 tasks. Look, how many threads are created? 8 threads are created. Can I comment this main, start main end? Now look at here. How many threads are created? How many tasks submitted? 10. For 10 tasks, 8 threads. Improve some more. How many threads created? 8. So with 8 threads, it is a managing. Okay. Improve some more. How many threads created now? 9. Okay, now 9 threads created. So tell me dynamically number of threads are increasing or not? Look at that. Now it is managing with how many threads? 7 threads. So what is the final discussion? How many ways we can create a thread pool? It is depending on the approach. Okay, 5 approaches are there to create thread pool. What are the 5 approaches? Single thread, new single thread executor, new fixed thread pool, new catched thread pool. And the remaining scheduled thread, you can ignore them, not required for us. This is sufficient. So can I expect all the people got clarity on this? Okay. Tell me what is the difference between executor and executor service? Executor executor service dot, it contain only what method? Execute, which will accept only runnable task. Now, I have a method called what? Submit now. This method submit method has, observe, 2 parameters, runnable parameter and callable parameter. What is the difference between runnable and callable? Observe now. Callable, let me go to API documentation better to understand. Runnable contains only one method called what? Run. What is the prototype of run method? Last 15 minutes, sir. What is the run method prototype? Is it return any value? No. Is it throwing any exception? No. Now observe. I have started my custom thread. I submitted my task. What happened to my task? Is it successfully completed or exception raised and failed? Is main thread no na don't know na don't know, because they are executing independent in their own path. Once you call submit method or when you call start method, both are disconnected. Main thread running in its own way, custom thread running in its own way, there is no connection. What happened in the other thread? I don't have any information, but I got a requirement. After my task execution completed, I want to get the information whether the thread completed or not completed. I want to know whether exception raised or not raised. For that, there is an alternative interface is given in Java 5 version. What the interface? Callable. Observe, callable is also a functional interface. Callable is also functional interface. It also contains only one method. Read this point. A task that returns a result and may throw an exception. Implementers define a single method with no arguments called call. The callable interface is similar to runnable in that both are designed for classes whose instances are potentially executed by thread. Callable implementation, runnable implementation, both are meant for running in the thread. But what is the difference? A runnable doesn't return a result, cannot throw checked exception. Callable can throw exception. Observe, call method return what? Value. Open this. Observe, it is throwing exception. So if interviewer ask a question, what is the difference between runnable and callable? 1 minute, sir. Let me write a question there. Otherwise, we may forget. Now, 39. What are the differences between runnable and callable? Runnable, both are functional interfaces. Both are meant for running their instances and implementations in a thread only. But runnable doesn't return value, doesn't throw checked exception. Callable return the value and throw checked exception. If you wanted to get some value from the custom thread to the main thread, then we have to use callable. Observe now, I wanted to implement callable to show you that. Callable is also functional interface. Can I write parenthesis, arrow, lambda expression body? Here, callable is a no parameter method, but it returns what? Value. So for return value, I'm writing one statement here first for understanding. System.out.println double quotes, call is executed and it returns some value. Return something, I'm returning what? Hi. Anything you can return, either value can return, you can return string, or you can return what? One array object or one collection object, anything you can return your wish. Now observe now. Save it. Executor dot single thread executed thread pool ready. To the thread pool I submitted, what I submitted? Runnable or callable? Callable. Let's see first of all, is it executed or not? Shall I comment this logic? Unnecessary many outputs will come. Commenting. Control F11. Look at this. Call is executed na? Now, when the call is executed, it returns value na? That value I have to capture. Currently, it is executing asynchronous way, synchronous way. Asynchronous. I submitted the task. Main thread is running in its own way and custom thread executing in its own way. Observe, main end we will get first. Main end will come first and then call is executed. Then how can we get this result? Further, observe, submit method is having a return type called what? Future. You have to write here what? Future. Future is a container object. It contains the result. What is the result you are returning? String. What I should write here? String. String future equal to why unnecessary I type. Let me ask Eclipse. Control 1 assign to local variable. Okay. Now observe here. I call the submit method. Submit method, what I submitted? Callable. Callable return result is available in which object? Future object. Now the question, listen carefully. Whenever I taken the return type into future, in this future object, what the result available? High available. Am I asking JVM to return that value to my main method? No. Then still you are having what? Asynchronous flow. Main completed, then the call is executed. But I want to get that result. To get that result, in a future class, we have a method called what? Get. All are catching my point? Repeating again. So what is the difference between runnable and callable? Runnable is meant for submitting the task and execute task independent of other threads. It doesn't return any result. But I want sometime result from the custom thread. For that, I have to submit what? Callable. When you submit callable, callable return the result. That result, if you want to capture, I have to use what object? Future. So what is a future? Future is an object that contains callable return result. Now, as long as we are not taking the value from the future, program execution is what? Concurrent, asynchronous execution. Whenever you ask, Arey, I want that result, tell me, this main thread will be blocked or not? What you're asking? Get the result from the future. Then the future object should contain this high result to get, na? That means, like a sleep method, morning class you learn, na? When you call sleep method, what happened? Main thread execution is pass. When I call join method, main thread execution is pass. The pass is nothing but what we call blocked. When you call get method, get method immediately passes the main thread until this callable is executed and result is captured inside future object. Everyone accepted? And tell me, what is the difference between calling get method without calling get method? If I don't call get method, what happens? Program execution is asynchronous. Concurrent flow will be there. Main thread execution is not pass. Observe, main thread execution is not pass. Main completed, call executed. Result is captured in the future object, but that future object able to access or not access? Not access, because main thread is completed. No, I want the result. Then what should I do? In the future, we have a method called get. Call the get method. Okay, Nana? If you call get method, what happened? Main thread execution is blocked. Here it is blocked. How long? Until the callable is executed, result is generated, return the result and stored inside this future object. Until then, it has to wait. Then that result I am taking into my local variable. What the result coming of what type? String. I have tried string result equal to, and then I am displaying that result. But it is throwing error because it will throw exception. Let me handle that exception. Interrupted exception and execution exception. Two exceptions it will handle. Okay, look at there. What is coming output? Main end coming after, na? Look at there. Callable result is coming or not? So finally, what is the point you need to understand? Executor framework is meant for creating pool of threads and for reusing. Point number one. Point number two. Custom way of creating thread objects by using thread class, not reusable. Burden on the JVM is increased. Application performance is decreased. Via executor framework, application performance is improved because threads are reusable. Okay. Next, how can we create a thread pool? To create thread pool, we have 5 approaches. Number 1, new single thread pool. Number 2, new fixed thread pool. Number 3, new cached thread pool. Number 4, new single scheduled thread pool. Number 5, new fixed thread pool. Okay, new fixed scheduled thread pool. So the 5 ways we can start. When we start the thread, how can we when we start the thread pool, how can we submit the task? For that, in executor service, we have a method called submit. Submit is a overloaded method which will accept runnable and also accept callable. I want to submit the task. I don't want any result. Then implement what? Runnable and submit. No, I want to submit the task. My task is generating the result. I want to capture that result. Then you have to submit callable implementation. Then by just submitting the callable implementation, is the result is coming back to our thread? No, I have to capture that result into future object. Just by capturing the future object, is the result coming to our program? No, you have to call what method? Get method. When you call get method, what happened? Program execute. I mean, the currently running thread execution is a block and waiting until the result is generated. Everyone understand? Suppose sometime it is taking lot of time to generate the result. Then get method will process until it is generate the result. Sometimes I don't want to wait. Then get method is a overloaded method. Look at there is something called what? Timeout. You can specify long timeout also here. If you specify timeout, how much time you give here, that much time only it will wait. After that, it will not wait, it will terminate and go out. So this is the complete story about executor framework. As part of executor framework, 2 points only you have to remember. What is a thread pool? What is the advantage? How to start thread pool? How to submit the tasks? How to capture the result? Difference between thread pool, difference between runnable, callable, difference between executor, executor service, executors. If you remember these 4-5 questions, then executor framework, any question you can answer. In Java 9 version, we have one enhancement called completable future. What is that? Completable future. I will give you quick understanding, just you explore in the Google. Listen, when you call future.get method, what happened here? The currently running thread execution is blocked. Now it is a asynchronous flow, na synchronous flow. Synchronous. Whenever the thread execution is blocked here, that means asynchronous flow is there. No. Now this thread is passed here. Until that other thread execution completed, it cannot running the execution. Why I should wait? I don't want to wait. I want asynchronous flow only. Then we have to use what? Call completable future. If you use a future object, it passes the thread. It passes the currently running thread and make it as what? Synchronous. But still I want asynchronous. I want to capture the result, but still I want asynchronous, because until the result is generated, this thread time is wasting or not. So that's why I don't want. Future has several limitations are there. To overcome that limitations, in Java 8 version, completable future, one new class is came. So tell me, future available in which version? 1.5. Completable future available in which version? Java 8 version. Java 8 version. Future has actually 5 limitation. To overcome that 5 limitation, completable future is came into picture. Clear? So completable future I will explain in the coming classes. I'll take one more workshop and you can understand it. So by that time, can you please practice this example? Okay. So this example I will upload. Where I can upload this example? For my students, regular students, I can upload in the Google Classroom. For other students, where I can upload? Okay, let me do one thing. All the people, just check in the Facebook. There is a page called fb.com/HK Programming World. Here I will share the program. From here you collect. Okay, what is the link? Go to Facebook and search HK Programming World. Your Facebook account? Create one dummy account. And I think you no need to have any account. Okay, directly you can copy. It's a page. Facebook account not required. Go to browser, type HK Programming World. No spaces. HK Programming World. You will get Facebook page. Click on it. Just close this. Sign up not required. Scroll down. Here I will share that program here. You can directly copy paste like this. Custom collection development, olden days. So many days back I shared. 2022. Okay. Copy like this and copy into your system and practice. Clear? So hope all the people enjoyed today class. Online students. Did you get some information? Nadeem Khan, no need to, this is not a group, a Facebook group, no. Facebook page. In page, there is no request. You have to like it and follow. There is a button called like button. After login, you will find a button called like button. You should click on that like and follow. Or follow button, some button will be there. Okay, long back I created this slogan. Now is a slogan, think Java, think HK, learning is simplified, believers, success is yours. And something I created. Okay. Yeah, I will share, Vaishnavi. Here, questions, answers, program, everything I will share here, okay? Just use this link to get the complete program. Questions, answers, everything I will share. Program, explanation, everything. Okay, now? Okay, next week, I will conduct one more workshop on the remaining multi-threading enhancements. Okay, now? So that time you can check. The same link you can use for the next workshop also. So I'll give announcement, the date and time, you can follow this. Okay, tell him multi-threading. Huh? It's not a, multi-threading. How audio video come at a time? That is both are sync as a one file only. That is a audio software, no video software. Multi-threading cannot be there. Okay. Thank you. That's all for today class. Hope you all enjoyed. Good night. Happy weekend.